Okay, so hello everyone. My name is Tome Walos, and I'm an UPC Tarrasa student that has been doing his Erasmus here in OPT. And today I'm going to present my work in the last month. Okay, today first I will do a quick introduction, then I will talk about Ragna version 4. Afterwards, I will explain you the bending 3D prints concept, and after that, I will explain my version of Ragna, that is the 5th, and finally, I will explain you my guessing of the future of the project. Well, this month I've been working in LOWQ project. That's a project that takes place in OPT, where the students can get in touch with the mechanical part of robotics, and meanwhile, the professors are doing the software part of the robotics. The two principal projects in LOWQ are Ragna and Bartho. And Ragna is a robot based in a spider shape, and Bartho is based in a cat shape. So the robots are powered by Tisco, that means Touch in Servo Controller, and it's based on OpenC3 and Arduino. So when I arrived, this was the last Ragna version by Andreu Aliu, who was another Erasmus student from Catalonia as well, and this was the naming convention. There was the hip, the thigh, and the shin, just as a person leg. So now I will explain my last upgrades of the Ragna version 4. So even though Andreu's design was very good, there had some remaining problems, just like play between base and hip, base weakness, thickness in the gear, that the gear was so thick that the belt moves in transversal, so it wasn't good for the movement. The tension of the belt wasn't good enough as well, and the critical angles were too big. So the first change that I did, as you can see here, was to do the bottom of the base thicker, and that solved the play between the hip and the base problem. And then I erased this hole because it had no sense, and it made the base so weak. So now I will explain you the change that I did in the shin and thigh junction. As you can see, this was the old one, and this one is my version of this junction. So what I did here is that in order to tension the belt, I made a part with a ratchet gear that it's a gear that moves only in one way. So I put the edge of the gear in an unconcentrical and in 2 millimeters from the origin. So as you can see in the video, it's just an animation, but as you can see, the edge is moving. So if you mount the edge and then you tense it with a tool, the tension in the belt will be soft. And then, in order to better mounting, I changed the shin top as well with this slot in order to mount it easily. So as you can see here, the legs are very similar, but with the last change that I did, that can be noticed here. And this is a final render of Ragna 4.5. Okay, now I will explain the bending 3D prints concept. Well, when I arrived, Jürgen explained me this 3D printing concept, that its goal is to to print a flat part with maybe some extra shapes, and then when the part is it's printed, you can bending it to achieve the shape that you want. So these have a lot of advantages, but the most important ones are the prints will be faster and cheaper, and you won't need that much support. So when we design in this concept, there are three considerations that we have to do. That's the 3D printer where we print, the materials, and the printing software. Okay, we used this printer. It was a Markforged Mark II, and it has that volume. And we used these two materials, Markforged Onyx and fiberglass. We used Markforged Onyx as a complaint, and it's a nylon with carbon fiberglass, carbon fiber. And then we used fiberglass as a support material and to do it more stiff. Okay, one of the most important things in the design was the software. We used Agar, and we used a gyroid field, that is a new field pattern that's very rigid in transversal and perpendicular forces, and we used the automatic settings, that it's very important in the design. And for the fiber, we used these settings, concentric fiber and inner hose only, because if we wanted to control the position of the fibers, this was the setting that allowed us to do it better. In the design, we have to put some strategic holes in order to put some concentric fibers around the hole. Now I'm going to explain the design factors of this concept. Well, the bending slot, as I told you before, the gyroid field had 8 layers in the floor and in the top. So we put a 0.95 millimeters in order to add a layer of fiberglass, the support material. And then I tried different distance between these two walls, and 0.5 worked well, so I keep that distance. And then, well, the angle can change, depends on the shape that you want to achieve. Okay, this is the climbing system. It's very important when you want to bend it. The first idea was to put some iron pins, but then when I was doing different tests, I realized that it could be better if the climbing system is in the part itself. So I kept going with this idea, and I will explain it now. My first guessing was to do it like this shape, like very straight, and the support, the surface that it's in contact with the wall, it's very thin. And then with the pass of the test, I realized that this is the best shape, that is better than that one, and it worked very well. So I have here, I have the tests. Oh, I have it here. You can see here that the walls between in the bending slot are so straight, and it's pretty robust. Yeah. So that was my last test, and this is like one of the first tests that we had that you can compare. Yeah. So this is my last version that you can get in touch with that one. And the most important things are the top of the hook, that, as you can see, have an angle in order to get in contact with the wall, and the wide hook geometry. Well, and the way I think that I achieved a very interesting part, it's very difficult to implement it in a part. So Jürgen and I decided to go on with the project with the iron pins, but I had this part in order to have a base for the future. So now I will explain you the Ragna folding leg. The goal was to replace these parts for that one, only one 3D printed leg. These are the shape, the unbended shape. As you can see, there are these holes in the bending gear slots that are made by me. But then you can also see here that there are extra fibers. We didn't want to add that fibers, but it's a software limitation. We can't decide to put it or not, so it was. I'll leave it there. And as I told you, we used iron pins and glue. So the design of the leg was very difficult because we misused SolidWorks sheet metal, because the process in the designing was to design it in the bending state, then unbend, and then put the slots. So even though it works, it's what you can see in the screen, it's not the reality. And that's because it's a unique and innovative design, so there is no software to do that kind of printing. Here you can see some renders of the bending leg. And well, in this case, we use this glue, this LOWQ glue, and it's a pretty good glue, and we use that because Jürgen talked to Henkel and they told him to use that in nylon. But for this proposal, it's not the best one because it's so fast. It's less than 5 minutes, and if you want to bend it and put the glue and bend it there, you are not fast enough to do it. So I would recommend in the future to do it with epoxy maybe, but it's very expensive. This is the final render of Ragna version 5. And now I will talk about the future of the project. I truly believe that this hook climbing system is very interesting for the future. So for me, the first steps to do in a short term in the future of this project will be to parameterize the bending slot and the hook geometry as well. And if it's mandatory, because I think that if the hook is good designed, the glue won't be necessary, change the glue. So that's my presentation. If the questions round. So that.
You mentioned critical angles.
Yeah.
On the previous, what are the critical angles? Can you show me?
Like this. So in this one, as you can see, you can change it. And in that one, I made it a little, well, I made it a little better.
So it shouldn't move further than a certain degree.
Yeah.
That's too far.
Yeah, well. Yeah. As you can see here.
Why did you move your gears to the outside? I didn't get the
Which gear? I'm sorry.
The black and the red one. I think with
yeah. As you can see, the bearing is thinner.
One of your goals was to reduce the printing time, but in your design with your hooks, you raised the printing time again.
Yeah.
Do you have an idea what's your profit still in printing time?
So, if you want to do like for instance a solid cube, you will need so much designed support, or maybe even though if you want to design like an empty cube, there will be support as well in the inside. So if we do it in a flat and we mount it there, it will be there will be a little bit support, but not that much.
Mm-hmm. So for instance, in this part, which is not the cube, of course, what is still your profit? What is your gain towards the printing time compared with your the clicking system?
Because In this one, compared with the clicking system, well, I think that even though the clicking system it takes more time, it's very interesting to have it all in one part. I think that maybe the printing time will be a little bit bigger, but that factor I think that it's pretty important and pretty good in the design. So that's what I think.
Where did you get the idea of using the hook mechanism?
Well, because I were doing some tests and then I saw a snap joint PDF, Adobe PDF. So I think maybe it could work in this case. So I showed my idea to Jürgen and he told me that it was nice. So I kept going with that idea.
So you have never seen examples of people using the flat bending printing
Yeah.
in conjunction with snap hooks?
I did a research about that, and there is no data in the internet. I didn't find that. I found just one print in the internet of a box do it with bending 3D printing, but the data of this project is there is no data of that. Well, so small data. So it was difficult to do some steps because every step that I did was new, but I think that as you can see in this test, it's pretty solid and robust.
Why didn't you use it in this case?
Because if you want to, well, that's what I put in the footer of the project. This test works very well in that case, but then if you want to put it in a bigger part, it's very difficult to achieve the great geometry to do it in that way, you know.
Now it's one size.
Yeah.
But you can upscale it or downscale it still.
Yeah.
Use multiple hooks.
Yeah. Yeah.
What I really like is the difference between this test part and this test part, because this contains an extra component.
Yeah.
There's a phrase in engineering which is becoming more and more popular.